We've looked at the reaction of alcohols with acyl chlorides, and now we're going to look at the reaction of amines with acyl chlorides. It's a very similar reaction, occurs through the same mechanism, nucleophilic addition elimination. So let us have a look at that. Right, so here's an alcohol. Sorry. So that would be ethanol, and we looked at the similar amine. That would be called ethylamine. Right, amines are very similar to alcohols. As you can see that you have got, there's actually a primary amine, but you've got an electronegative element with a lone pair on it. In that case, we've got nitrogen, and in this case, we have got oxygen. Of course, oxygen has actually got two lone pairs. We'll just draw one on there. And we've seen that how are they going to react with an acyl chloride. So if I draw an acyl chloride backwards, well, in the case of the oxygen, the lone pair is going to attack that carbon, because of course that carbon is delta positive. So that's the nucleophile there. In the case of the amine, the nucleophile is, well, it's the lone pair on the nitrogen this time, is going to attack that carbon there. And in both cases, what's going to happen is once they're going to form a bond with that carbon, you're going to break the pi bond. Okay, so the mechanism between an amine and an acyl chloride is extremely similar to the reaction between an alcohol and the acyl chloride. Sort of a question which you might ask here is to say, well, we've seen that alcohols can react with not just acyl chlorides, but they can react with carboxylic acids. Can amines react with carboxylic acids? And they can, but the rate of reaction is so slow, and that it's not a very efficient reaction at all. So really, for all intents and purposes, the amines only react with the more reactive carboxylic acid derivative. They only react with the acyl chloride. Okay, so let's have a look at the mechanism and just draw the whole thing out. You can probably guess what it's going to be already. I'm going to draw my acyl chloride here. And here draw the amine. I'll make it methylamine. So got a lone pair on the nitrogen. We've got our delta positive on this carbon. That is going to attack there and form a bond. Of course, that means that this carbon, one of the bonds has got to break, and it's the pi bond which breaks. The pair of electrons go onto the oxygen. So we draw the intermediate there. We've got CH3, we've got a negative charge on the oxygen now. The chlorine is still attached. The nitrogen, negative on there. The nitrogen has got two hydrogens attached still, and a methyl group. And you should realize that you've got two neutral species here. So this is the acyl chloride, which is neutral, and the amine, which is neutral. And we've now got a negative charge on this oxygen. So that means somewhere else we must have a positive charge. And you probably realize that the positive charge is going to be on the nitrogen. That nitrogen is forming 4 bonds. Normally when nitrogen forms 4 bonds, it only forms 3. Normally when it forms 4, it's usually got a positive charge on it. Okay, so the next step in the mechanism is the same as before, is that the pi bond reforms. So the pair of lone pair on the oxygen there goes back to form the pi bond. This carbon is now forming too many bonds, so now we've got to lose this. This comes off as a chloride ion. Yeah. So if we draw that, CH3 and the final step in the mechanism is we're going to lose one of those hydrogens. In reality, that hydrogen will be picked up by an amine. We can just, it's perfectly acceptable to show it here, it's just dropping off by itself. So that goes back into there, and we have now formed this. Okay. And at this point here we get a Cl minus coming off, and at this point here we get an H plus. So we're eliminating HCl effectively. So now we've got this thing here, right? You probably can see that there's a lot of similarity between this and an ester. So you have a carbonyl, you've got a carbonyl carbon here, and then attached to that is an electronegative element. In the case of the ester, you've just got an oxygen there. In the case of in this, you've got a nitrogen. Okay. Now this class of molecules, I like to think of them as being like nitrogen esters, but they're not called that. They're actually called N-substituted amides, which is a bit confusing. Okay. This is an N-substituted amide, and you need to know how to name these things. Okay, so what I'm going to do on the next board is I'm going to draw some esters, and we're going to name those, and then we're going to draw, if you like, the corresponding N-substituted amide, and we'll try and name them. But this one you would actually call, you'd call this one, right? You've got a methyl group here attached to a nitrogen, so it's called N-methyl, and then you've got this bit here, and that is called ethanamide. So that will be called N-methyl ethanamide. So now I just want to talk about what an amide is and how that's different to an amine and how we name them. So right. So I think I'll clear that. Okay, so right. An amide, an amine is just an alkyl group attached to an NH2. Okay, so e.g. you can have methylamine or methylamine. You can have ethylamine. And so on. Amides, well, they're kind of like carboxylic acid derivatives, because amides, you have an alkyl group, and then you have a carbonyl carbon, and then attached to the carbonyl carbon, you have an NH2 group. Okay, so we could have this, which is called ethanamide. If it was two carbons, as long as it would be propanamide, and so on. Right, and just to remind you, then, well, what do we have last time? We had the product in the addition elimination reaction. We had this, but here we had a methyl group attached. So this is called an N-substituted amide. This one here. This is not an amide, this is an N-substituted amide. And it is made, well, if you think it's, it is where one of the hydrogens on the amide group has been replaced by an alkyl group. Okay, so this one would actually be called N-methyl ethanamide. And that's where the name comes from. And I also think the names are a little bit misleading here, because it makes it sound like this N-methyl ethanamide has been made from ethanamide, and you've got rid of one of the hydrogens and stuck a methyl group on there, and because you haven't made it that way at all. You've made it by sticking together these things. So you've made it by reacting methylamine with the acyl chloride here. This bit is an acyl chloride. Well, it comes from the acyl chloride. Okay, so let's compare some N-substituted amides with esters and just see how similar they are and how the names are fairly similar. Okay, so if I clear that. Okay, so I'll draw some esters here. Okay, so I've got 3 esters there. What would we call these? Well, this one, we have got, it's been made from methanol and from ethanoic acid, or the acyl chloride, and so we would call this one methyl ethanoate. So let's have a look at a corresponding N-substituted amide, which is very similar to this. So I'm going to have CH3, C double bond O, and I'm going to replace that oxygen there. I'm going to replace it with a nitrogen. Okay, and of course nitrogen always forms 3 bonds, so I need a hydrogen on there. Right, what would we call this one then? So I underline, so you've got a methyl group there, and this bit here, you'd call this N-methyl ethanamide. Okay, let's do the second one then. So this one here is formed from ethanol and from propanoic acid, or propanoyl chloride. So we'd call that one ethyl propanoate. Do it in blue, sorry. Propanoate. And the corresponding N-substituted amide would be CH3, CH2, C double bond O. Get rid of that oxygen, replace it with a nitrogen, and then we'd have CH2, CH3. And what would we call this one? Well, you'd call this one N-ethyl this time. And the amide, if you like, is propanamide. So N-ethyl propanamide. This one here. Okay, so we've got methyl this time. And the carboxylic acid, or the acyl chloride, is butanoic acid, or butanoyl chloride, so methyl butanoate. And if we draw the corresponding N-substituted amide, we've got CH3, CH2, CH2, C double bond O. Replace the oxygen with a nitrogen. Okay, so this has come from methylamine, and this has come from butanoyl chloride, so we call that N-ethyl butanamide. Okay, so that is the N-substituted amides for you. And again, I like to think of them as being nitrogen esters, but they're not called that. And the only difference between them and an ester is you've swapped the oxygen for a nitrogen. Okay.